Guys, welcome to an N2E robotics workshop. Oh wow, not Mike Russ, but I'm actually the host. And today I'm going to be talking about PCB designing with easy EDA. So yeah, before we get into it, I know that some of you have heard of Eagle, possibly KiCad, and all those other PCB designing softwares. I'm not going to be going over those because I feel like personally for me, it was a bit complicated. Like when I was first getting into PCB designing, it easy, not easy EDA, Eagle and KiCad and Altium and all those other ones. They were not very beginner friendly. They were really complicated and really convoluted, especially Eagle. Eagle I didn't really like using very much. That doesn't mean that those are bad programs. I'm sure those are also very good PCB designing programs, but I feel like easy EDA just makes this whole process more accessible. And especially if you want to just do simple projects, simple electronics projects or personal projects or whatever, this is probably the easiest way you can go about it using this website right here. You can actually create your own account with Google. That's why I just use one of my Google accounts to create an easy EDA account. And they also have like a cloud storage and everything. So you can have all your projects, different projects listed here on the drive. So if you want to work not on your personal computer, you want to work somewhere else, okay. They're on cloud. So just log in wherever and you'll be good to go. Okay. So let's get started with one of the first parts of PCB design, the schematic. Okay. So some schematic tools that you're going to be commonly utilizing pretty much every software are the wiring, pin component and placement tools, uh, custom items in case you have your own personal components that you want to import into Easy EDA, and labeling. So let's start off with what our schematic looks like here. I've got a simple 4-digit 7-segment cathode display here. It's basically like you can make a timer with this if you wanted to. You could just make any sort of display if you wanted to make it display hey or something or 1 2 3 4. You can do that uh, with simply just a microcontroller and the cathode display. So the microcontroller I use for this schematic here, and we're going to be using in our demo today, is a TNC4. Really good microcontroller. Highly recommend. If you have an Uno, that's fine too, or a Nano or whatever. And yeah, it's not too complicated. It's just a microcontroller, some resistors, and the display itself. So in order to just create a schematic, all you have to do is when you first open in your first tier, right? You can click on new project here at quick start, or you could just go to project and then, click new project here. Okay, I already have a project opened and it's for our cathode display. So in this cathode display, we have a couple tools that we can use here in this section called wiring tools. Now, first and foremost, you're obviously going to need the wire tool, shortcut W. And what the wire tool basically does is that you can essentially um, click on a pin ending or a component ending after clicking here or pressing W. Oh, not that. Yeah, you could just click on a pin or component ending and then attach it to another pin, or if you attach it to another wire, it'll form that red dot to let you know that, okay, they're intersecting. Otherwise, as you can see here, these wires aren't intersecting, so there's no red dots here. Okay, so that's the first tool. Next tool you might want to be familiar with are the ground and net 5-volt or net VCC flags. That is basically to designate, okay, these pins are going to be getting, you know, the overall ground and overall power. So my net 5-volt flag is going to be connected to this pin right here, which is going to be connected to VIN on the teensy. This is just so that, let's say I wanted an external power source and I wanted the cathode display to be on even when the microcontroller is not connected to my computer. I can have it be powered by an external battery of some sort. And then, of course, there's ground. So those connect to VIN and ground on the teensy. Arduino, I think, has similar pins. The Uno, the Nano. Pretty much every microcontroller should have similar pins for external power supply. Next, what we're going to be looking at is the no connect flag. So the no connect flag is important because when you're going to be converting the schematic into like the PCB footprint, you want to let the program know which pins you're not going to be using, which connections you're not going to be using. So I'm going to remove this one here. I'm going to remove this one here first, if I can. All right. So yeah, that ground no connect flag right here. Go on that, place it there. If you place it anywhere else, it'll give you an error message like saying no connect flag can only be placed on a pin dot or the wire which is connected one pin. So you can't just place it anywhere on the schematic. You have to place it where there is a net. Okay. And then there's a pin tool, which let's say you have you want to set up certain connections on the board that are not like related to any component or whatever, just your own personal pins that you want to attach. Either attaching to another board or something. We have some wiring or whatnot or cabling. You have the pin tool, which you can also assign nets to and then connect to other pins. We're not going to be really using that. I'm just showing you, that is a tool that you can use. And there's also, oh, is that it? Huh, okay. No, that's not it. Okay. Yes, component placement. That's what I wanted to talk about next. Okay, so if you go on the sidebar, you'll see a couple of things on the side here. We're mainly going to be focusing on the Design Manager tab, EE Library tab, and then just the overall library tab. This I'm going to get into a second, but first I want to go over the EELib first. So in the EELib, you'll see that you have a couple things here. You have some groups of resistors, you have some groups of capacitors, inductors, power supplies. You also even have some like basic components here. For instance, I got the 4-digit cathode display from this section right here. So if I wanted to, I could also have like a 1-digit cathode display, or I could place an OLED screen here, hook that up to the teensy. These are mainly so for convenience because I think these are commonly used in a lot of EE projects or personal projects. That's why they included these here. There's also some basic regulators and whatnot. So basically, the most common components can be found directly from here. And if they're not listed here, you can still go to the library and search up the component names for yourselves. Like for instance, the teensy component, it's not directly provided by the EE libraries. You have to get it. You have to get a custom component for that. So what I did was just look up teensy 4.0 and go to the user contributed tab, because for specific parts like this, typically other people have made them for you, and I find them. Do check beforehand before you use any third-party components or components made by other people. Like, just do a quick glance over them. Like, okay, are all these components correct? Are they all in the right place and whatnot? And I chose this one right here. because it has all of the pins that are on the teensy on the sides. There are also tins below. There are also connections below the teensy, but I didn't need to use them, so I didn't really feel like getting a footprint or a schematic for that. Okay, so other than that, a neat trick when it comes to placing components like resistors or capacitors or whatever is that when um when you have them placed, there's a there's a convenient shortcut when you're wiring through multiple resistors in a row. Like let's say I had two resistors here. I don't, but let's just say for the sake of argument that I did. And I don't want to just, repeatedly connect from here to here and then here to here and then here to here. Right? What you can do instead is you can just click on a component ending, go through them, and then click on the destination. Oh, it's not what the destination is. And it will automatically wire through the components you had in a straight line. So if these are all placed in the same line and you're wiring through them, it'll automatically wire it for you. And then of course there's also the basic, if you want to rotate some components, you can do so on the schematic, just to make things a little more convenient for placement and whatnot. Um, also change, which is my next point. You can also, I just went over that component items. Oh yeah, you can also import, by the way. So if you have a component that you specifically made or something like that, you can export the DXF file if you know how to do that. I'm not going to be covering how to make your own custom components. That'd be an entirely different workshop, where you could just import in an image, which I actually did here on the schematic. I imported in a N2E Robotics image right there at the bottom. Yeah, and in terms of labeling, so you want to label what some certain components are like. Let's say you don't want this pin to be named which one. You want it to be named power pins. Come on, why didn't it change the text? Power pins. It's not changing the text. Okay, fine. There we go. That's strange. I should be able to delete them, so I don't know why it's not letting me edit the text, but whatever. So you can change the labeling on different components. You say if you don't want them to be like random words identifying what the component is, you can just write, okay, these are the power pins or whatever, and these are the current limiting resistors and whatnot. What else should do? Oh, right, canvas attributes. Right. So additional features for when you're editing in the canvas. You'll see that you have a couple of options for zoom in, zoom out, fit in window. Uh, the important things here are the grid size and the snap size. So the grid size is basically going to do is it's basically going to adjust the size of these squares in the background. So you have like a visual guide of where you need to place your components or how you need to space them. And then your snap size is basically going to align with that. It's gonna dictate how much the components move as your mouse moves. So let's say I want snap size of 25. These components will shift a lot when I shift my mouse, but they will shift in exactly 25 units and both up and down and side to side. And if you want a more uh, finer adjustment, you can hold Alt, or maybe that only works on the footprint side of things. You can always change the snap size back if you want a more precise placement. so that it doesn't snap to 25 units each time. You can just move it 1 unit at a time. And if you also want to, oh, right. Is that? Okay, no. No, that's it. That was, I was thinking of if you also wanted to change the net of the pin, you can do so here, but I think you have to do that when you get to the footprint side of things. Okay. So now the footprint side of things. So once you have made sure that all of your connections are in place and you have no like loose nets, like, you know, your 5-volt net is properly connected, your ground net, your T1, T2, whatever, all those nets are good, and that there's no like missing connections or whatnot. Then what you can do is you can go to design and then you can convert your schematic into a PCB. I have to save it first. Okay. And there you go. This is what your file will initially look like. This is going to be your board outline. Your board outline is where you want to place your components into, because this is where your PCB, this is basically going to be the shape of your PCB, and everything will go onto here. You can just place the components however you want to. This is a very bad arrangement, but just showing. These blue lines, what they indicate is which pins will connect to which pins. So the blue lines are going to be connecting to pins that share the same net. Right, so if you press W, again, wire tool, or actually in this one, it wouldn't really be the wiring tool, it would be the routing tool. And that's going to basically indicate which, yeah, okay, so this pin is connected to this one right here. Yeah, and the white line is going to indicate, okay, this is how you can do it. Typically, you don't want to make 90-degree routes like you see here. It's not that important for like small scale projects, but I think it's still good practice if you make 45-degree turns whenever you're routing connections to different components. Again, it's not that important. It's more important when your circuitry is like susceptible to like uh, interference, like noise interference. Um, you're probably not going to have that issue. But it's just good practice. And it looks cool if you do it in like 45-degree angles. Okay. I'm not going to write all this. And actually, I don't have to route all this personally, because there is a neat function here for routing all these components called the auto router. What the auto router does is it essentially routes everything here on the board for you. So how you access that, you have to go to route auto router, and then you have to specify, okay, what's going to be the length of each route, so the track width, and what's going to be the space in between each track, the clearance, via diameter, via drill. Don't worry about that too much. Just click run. I wonder if this will turn out well. It actually didn't turn out too bad. Okay, because if your projects are a little complicated, the auto router might have some errors. Like it does have limitations in really big projects or really complicated projects. You might want to avoid using the auto router. Another thing the auto router tends to do is it tends to place vias when it might not necessarily need to place any vias. Why that's bad is because vias, while they are useful in case you have like a lot of different connections, you can go to your connections can go through to the bottom of the board and then connect to the top of the board, so that you have more room to work with. But typically, that might affect the performance of whatever project you're trying to do if you use too many vias. So yeah, it's best if you have like a straight line connection on the same plane of the board. Okay, I'm not using this. I already have one configured here. It's this is the same display, and you'll notice that it's like filled in with red, and I will get to that in just a moment. So yeah, in footprints, basically you have these different layers, and the main ones we're going to be focusing on is the top layer, the bottom layer, the top silk layer, the bottom silk layer, and the board outline. Board outline I already went over. It's just the uh, pink looking one right here. It just indicates what are the dimensions of your PCB. What's the shape of your PCB. There's the top and bottom silk layers. What the silk layers are is they are basically like text on your board. So I have a board with me right now that I made last year for Micromouse. Um, Basically, the white print on this board, that's the silk screen. And I also had some on the back as well. So yeah, silk screens are really useful for indicating which pins are where and how the components are orientated and like which components go where. Um, yeah, so here, this is the teensy uh, silk screen, and this is the display silk screen, and these are the silk screens for the individual resistors, and this is the silk screen for the power pins. And then there is the top and bottom layers, which I should have gone over first, but I didn't. It's okay. It's whatever. Top and bottom layers are essentially the top copper layers and the bottom copper layer. So yeah, you can see it if you go here. You know, these are all the non-copper layers, and these are the copper layers. The copper layers are essentially where your connections are going to go through, right? And you'll see we have some connections here on the bottom copper layer, and most of them usually are on the top, unless you have a really like you have a ton of connections. Then you're also going to have a lot of connections on the bottom layer as well. Okay, so yeah, vias I already went over. Vias basically connect connections between the top and bottom layers, or they connect connections between different layers. They make sure that they could go in between. And yeah, as I said, it's important when you have like a lot of nets on the board, like way more than like too many to just have on all on one layer. Like you need multiple layers to house all the connections. And then yeah, so this red here, you may have noticed that the other one, you know, the entire top layer wasn't like red. And the reason for that is because of this right here. So what I essentially did was I clicked on this tool, the copper area tool. You have access to it with the E shortcut. And you can select which net you want that copper area to be connected to, right? And then just select where you want to start. And I'm just going to highlight the entire board. And then once you're done, like going over the area you wanted to select, just hit escape, and it will automatically fill in the region you traced over. So as you can see, the copper area is avoiding all connections that are not named to ground, and it's only connected to the pins that are attached to ground. As you can see, it's probably a little unnecessary to have a ground layer this big here. It is useful to have like ground layers on your PCB. That's mainly due to like uh, you know, heat dissipation and whatnot, to make sure like the heat when your project is running, it's not like just focused all on one place or one component. You know, it can like spread out over the copper area here. This is a bit unnecessary because cathode display doesn't generate this much heat, and the TNC has its own ground plane anyway on its own PCB, but it's whatever. This is just for demonstration purposes. some additional features. You can place holes on the board. So there's no shortcut for holes. You have to click here in PCB tools. And this is for when you want to, you want to have like, maybe let's say you wanted to screw the PCB onto something like a wall or whatever. These holes are there for you. You can adjust the diameter of these holes as well. If you want to make it like 5, you know, there you go. What else? There is also, right, the image inserting tool. So this silk screen, you can't just print it out by clicking text. You have to actually import an image into the footprint. So we go here. What I did was I selected N2E Robotics again. Let me see if I saved it. Yes, I did. And you can insert the image into the PCB. That's really big. Should probably reduce the size of that by 10. There you go. You could add whatever components you want, whatever images you want onto the silk screen just to make your board look more fancy or more fun or whatever. That's up to you. You don't have to if you don't want to. And oh, this is the coolest part about this program. I think this is really cool that they added this. Once you're done, like laying out your PCB and you have finished all the routes you've placed on all the footprints and whatnot, and all the silk screens, you can actually view the 2D model and the 3D model. Now, this is really cool because you can see your components like directly on the board. You can't see the teensy because it's a third-party component, but the cathode display you can see the SMD resistors I selected. They're directly on the board, and so this gives you a pretty good image of what your PCB will look like if you assembled all the components onto it and whatnot. Yeah, see the back as well. Rotate it. And once you're done with all of that, you can send out this board for fabrication. So if you don't want to get it from JLC PCB, you don't have to. You can just generate the Gerber files. I don't know what I changed, so I'm not going to save it. Hang on. Okay. So yeah, if it's going to ask you first, okay, would you like to do design rule checking to make sure there are no faulty connections or you didn't mess up something by accident? Okay, and it's good. So now it'll also give you, if you want to order from JLC PCB, it'll give you the direct price estimate, and you can click this button right here to order directly from their website. You don't have to generate your own files or anything. Just click that. Order data generated. Okay. It's going to take me there. It's going to process the Gerber files, and it's going to give me a little price estimate here, $5. And I believe you get 5 boards, if I'm not mistaken. So yeah, this is a little preview of what it would look like if you had a green solder mask. If you wanted a different color, you can always do that. Select red, yellow, blue, white, black. I think green is the cheapest. I'm pretty sure because green is the most common PCB solder mask color for some reason. Sorry, not. Yeah, I don't know why it's the most common. It just is. You can choose how many layers your PCB has. So if you're doing like a really complicated project, you might want to use Altium then. But if you're doing a really complicated project, you can select, okay, my PCB is actually using multiple layers, like it's using 6 layers. And you can select the dimensions. Obviously, since I imported from Easy EDA, dimensions are automatically there. You can select how many you want. You can get 5 or 10. typically you want to get, I would say, I personally, if I want a lot of boards, I'll get 10 because I don't see myself needing the same board or 20 of them. If you do, that's available to you, and it's not that expensive for the most part until you start really, you want like 1,000 boards or something, then it might be. But even for 1,000 boards, $300 is not that much. And if you don't want to order from JLC PCB, that's fine. There's multiple other PCB manufacturing websites that sell for around a similar price and whatnot. And delivery varies. It's not always 3 to 7 days. Especially since we have the whole quarantine situation. It might take a bit longer. Yeah, and you can also, you have some different options here. You want your surface to be finished with HASL with lead, or you can get lead-free HASL, whatever this is. I don't know what surface finish that is. The lead-free one will cost you more, and this one will cost you even more. As you can see, the price jumped up a lot. This is the cheapest option, but if you want a lead-free surface finish, that's fine. The copper weight essentially indicates how much copper is going to be used in your traces and your copper areas. You can use 2 ounce or 1 ounce. As you can see, again, the price jumps up if you use more copper weight. Yeah, it jumps up to 21. 1 ounce is typically good if you're doing a simple project. 1 ounce copper weight should be fine, unless your project is has high current or high power project. Then you might want a higher copper weight. And yeah, you can also adjust the thickness here. That's pretty much it, I think. Right? Okay, yeah, that's it. It's it might be a lot to take in at first, but once you get started with designing, it's actually not too bad. Just drag and drop the components, set up all the connections you want. Make sure that, you set up the connections like doing your research. Okay, like, oh, this won't blow up if I route it like this. There is also like a what do you call it? They have a simulation mode, but I'm not entirely sure if that's too reliable. Um, I would just double check yourself to see if your connections are proper before going on to order your PCB. That's what I did. In Micromouse, I tested, okay, these connections will be fine. Like, got a breadboard and tested out all the wiring and whatnot. And yeah, okay. So any questions? Is there anything you want me to go over, or you feel like I didn't cover?
Yeah, I have a quick question.
Yes.
How'd you get the pin headers into the schematic?
Which pin headers? These ones?
So, yeah.
Okay. So yeah, that's a common component, so it can be found in the EE-lib. And I think these are female pin headers. So you just go to here. No. Which one did I select? I think I selected this one. Yeah. So you basically select, okay, if you want a male pin header, it's going to say HGRM 2.54, 1 by 1. 2.54 stands for the standard pin spacing, 2.54 millimeters.
Got it. Okay, so you just run it through. So, like when you're wiring it, you just run it through both sides, so that's like the one side's connected to like ground, and the other side's connected to ground on the other board. Okay.
Yeah, this is this part right here. It's just to make sure that like, oh, okay, this is a 5-volt connection. Like,
Mm-hmm.
these pins are connected to 5 volts, and this pin is connected to ground.
Right.
That's what these fives are there for.
Yeah.
If anything, I'd say they're more for you. I would say include it. You don't. I don't think you have to include these flags necessarily, but it's important. And I think if you were to use the simulation mode thingy or whatever they had, they require you to connect to have a net ground flag and a net 5 volts flag. But yeah.
Okay.
So any common components like pin headers or capacitors or resistors,
Right.
they'll typically be here. Even switches and keys are here.
Okay.
Uh, you know,
So let's say that you put something like in your like system, right? You want to put a motor, right? Um, I'm assuming it wouldn't show up on the board itself. It would just show up on the like it would show the pin headers that you put in and not necessarily the motor itself.
yeah. If it's not a component like sourced by uh, like Easy EDA or like one of these JLC PCB assembled or LCSC or any of their own personal system components. Like
Mhm.
if you don't get it from there, uh, when you're trying to view the 3D model, it won't show up.
Okay.
Only their own components show up when you're on the 3D model. Maybe there is a specific way to make them show up, but I'm not entirely sure as to how you would go about doing that. I think it's fine.
Okay.
Um, as long as you have the footprints for them, um, it's good enough to give you an idea of whether everything will fit properly onto the board.
Right. Okay.
Actually, um, I did use that feature uh, in this board I made right here. As you can see, there is there's this white footprint for this box thing here,
Yeah.
the two holes on the end. That was for the motor housing, and this footprint it wasn't really even a component or anything. It didn't connect to anything. It was just to let me know that okay, I can't place my motor driver here, or I can't place these pins here. Uh, it's just to
Right.
give me an idea of how it would turn out. So footprint is generally good enough. And if you don't have the footprint, you can always get it from the third party library, or you can make it yourself.
Mhm.
Um, you can actually make your own footprints here as well, and then save them and then use them in your projects.
Okay. Understand.
Okay. Any other questions as to how as the schematic tools or the footprint tools, or any questions in general, like how did I do this or how did I do that?
I mean, this basically seems like CAD but for circuits.
Yeah, it is. It really is just CAD but for circuits. In case you're wondering how this works, uh, this display specifically, um, these uh, these digits here or these different segments. That's why it's called a 7-segment display. Uh, on each digit, they correspond to a different letter. So this top segment right here corresponds to A. This corresponds to B, C, D, E, F, and G. And then there's another segment for the decimal point or dot point or whatever. And for multiple digits, since this is a cathode display, you have to pull one of these pins to low and then, send out the different connections to one of these pins to display the digit or symbol or whatever you want on the display. You can display multiple digits at once. You can display no digits at once. It's up to you. But since this is a cathode display, if you want to display a digit, you have to pull one of these pins to low. So yeah, in case you were wondering what this exactly is. Do they go over for those of you in ECE department? Do they go over how to use the 7-segment cathode displays?
I think we do in DSD, but that's like a senior year class.
Oh, okay. Okay. I remember.
Uh, in DLD, Kagiana shows like how a 7-segment display works.
Okay. In Compark actually, my professor went over how like a 7-segment display would be programmed. We obviously wouldn't go over the hardware because I'm a CS major. I'm not an EE major. But yeah, yeah, that's I actually didn't know at the time that was a 7-segment display, but I thought it'd be cool to do it in this demo. So, and plus, the reason why I did it is because it shows up on the 3D model, which gives a good visual. Okay. How long how long does this workshop last? I'm just wondering.
It's usually till 8, but
Okay.
if we have no more questions and you presented all of your material, I guess we can end early.
Yeah, that's what I was wondering. Because, like, again, this PCB designing, it's not really that
Yeah.
extensive. It's like it's very simple. It's like the more simple part of the PCB making process. I'd say the more complicated process would be like when you're making the PCB yourself, which I'm gonna be doing soon.
Cool.
Using the CNC, using a CNC miller.
Mhm.
You have to do a bunch of things with the Gerber files and converting it to G code and whatnot. That'd be a different workshop. That's why.
Definitely. But yeah, thank you so much for this.
No problem. No problem.